We just learned half retail location model. Now let's do a practice. So this is a practice question. The problem is from the textbook on page 236. So if you look at the map, there are 4 customer areas. It will be A, B, C, and D. So 4 customer areas, and we also have the total expenditure for each customer area. For example, in community A, the total spending will be about $200,000. For community B, $100,000. Community C, $300,000. And community D is $200,000. So that's the total expenditure spending on shopping. We also want to find out what are the locations for the stores. The first store is called existing store. So this is a little bit unusual compared to the previous case, the example we just covered. In this example, the existing store is located right inside community D. So it's the same location as community D. So that means for those who live in community D, it's very convenient. There's almost no travel distance. The store is right inside community D. They are same location. Store size is 1. This is the current store, existing store. What about the proposed store? So where are we going to build the proposed store? The proposed store will be inside community C. The location of proposed store will be the same as the location of community C. So they are the same location. So for those who live in community C, can imagine this is a very attractive store because it's so convenient. The store size for community for proposed store is 3 compared to store size for the existing store is 1. So now it's much larger. So we want to assess 2 stores, existing store with store size 1 and the proposed store with store size 3 to see which one is more attractive, how much market share each of the 2 stores will capture. We look at the whole region. So let's apply the half retail location model. Step 1 is about calculating travel distance. So again, how do we calculate travel distance? We look at the map. We measure distance by metropolitan distance. So we're going to look at a travel distance from each customer area to each store. So first of all, let's look at the travel distance from customer area A to the proposed store. Proposed store is actually in community C. So basically, what's the travel distance from A to C? From A to C, because the proposed store is right inside community C. So A to C, what's the travel distance? A is right here, C is right here. So what's the travel distance? Will be 1, 2, 3, 4, 5, 6, 7, 8. So it will be 8, the travel distance. What about the travel distance from B to the proposed store, which is C? From B to C, what's the travel distance? So B is right here, to C is right here. So it'll be 1, 2, 3, 4, 5, and 6. So travel distance is 6. What about from C to the proposed store? As we know, the proposed store is right inside community C. So that's why travel distance is basically 0. Almost no travel distance. What about from the customer area D? D is right here to the proposed store. So what's the travel distance? So it'll be 1, 2, 3, 4, 5, 6, and 7. So travel distance 7. Now let's also calculate or measure the travel distance to the existing store. So first of all, from A to existing store is right inside community D. So first, what is the travel distance from A to the existing store? So basically from A to D, what's the travel distance? A is right here, D is right here. So it'll be 1, 2, 3, 4, and 5. So it's 5. So what about from B to the existing store? So B to D, what's the travel distance? So B is right here, D is right here. So what's the travel distance? So 1, 2, 3, 4, 5, 6, and 7. So travel distance 7. What about from C to the existing store? In other words, what's the travel distance from C to D? From C to D, C is right here, D is right here. So it'll be 1, 2, 3, 4, 5, 6, 7. So it's 7. What about D to the existing store? The existing store is located right inside the community. So that's why travel distance is 0. It's almost 0. Now we have the travel distance from each customer area to each store. We move to step 2. So this is step 1. This is the result. We move to step 2. Step 2 is to calculate the attraction of each store in each customer area. So here, for this particular application, the lambda value is given, which is 2. So we use lambda 2. So recall the proposed store, the size is 3. The existing store, the size is 1. So let's calculate the attraction. So first of all, what is the attraction for the proposed store in customer area A? What we can do is the numerator, store size, which is 3, denominator, travel distance, which is 8. And we do the power function because lambda equal to 2, so squared. So what is the attraction for the proposed store in customer area B? Again, numerator is the store size, which is 3. Denominator, 6, is the travel distance between B and the proposed store. So again, we do squared because of lambda. So what's the attraction for the proposed store in customer area C? Numerator is 3, store size. Denominator is travel distance, which is 0. So you can see from 3 divided by 0, which is infinite. So we write down infinite. So what's the attraction for the proposed store in customer area D? So numerator is 3, store size. Denominator is travel distance 7. So you get 0.0612. So now we have the attraction for the proposed store in each area. We can apply same procedure to calculate the attraction for the existing store. So first of all, in customer area A, store size is 1. Existing store size is 1. Denominator is 5, travel distance lambda 2, so 0.04. What about customer area B? Numerator is 1, store size. Denominator is 7, travel distance, you get 0.0204. What about C? Numerator is 1, store size. Denominator travel distance 7, so 0.0204. What about customer area D? Numerator, store size 1, denominator travel distance, which is 0, so that you get infinite as well. So what's the total attraction for each customer area? The total is 0.0467 plus 0.04, you get 0.0869. Total for B, 0.0833 plus 0.0204, you get 0.1037. Total for C, infinite plus the number, you still get infinite. Area D is 0.0612 plus infinite, you get infinite. So this is the attraction, step 2. So we just completed step 2. Now we move to step 3. Step 3 is about calculate the purchasing probability from each store in each customer area. So first of all, let's look at customer area A. How likely those who live in customer area A will shop from the proposed store, and how likely they will shop from existing store. As we discussed, based on attraction. So we allocate travel probability proportionally based on attraction of each store. So if you look at customer who live in area A, how likely they are going to shop from the proposed store. So we use that 0.0469, which is the attraction of the proposed store in customer area A, divided by 0.0869, which is total attraction for 2 stores in customer area A. So you get about 54%. So there's a 54% chance customers who live in area A will shop from the proposed store. Similarly, we can calculate for the existing store, so which is a 0.04 attraction for the existing store divided by 0.0869, which is total attraction. You get about 46%. Total, of course, is 100%, 1.0, 100%. So what about customer area B? Customer area B, so 0.0833, which is the attraction for the proposed store, divided by 0.1037, which is total attraction. So you get about 80.3%. What about existing store? So 0.0204 attraction divided by 0.1037, a total attraction. So you get about 19.7%. The total is 100%. Adding these two numbers, you get 100%. What about customer area C? So it will be infinite divided by infinite. So if infinite divided by infinite, you get 1.0, 100%. What about existing store? It will be a small number divided by infinite. So anything divided by infinite, you get 0. Okay, nobody will shop from existing store because the proposed store is much more convenient. Total is 100% as well. For customer area D, first of all, attraction 0.0612 divided by infinite, so you get 0. So any number divided by infinite, you get a 0. Then for the existing store, so it'll be infinite divided by infinite, will be get a 1. So total is 100%. So now we are done with step 3, calculate the purchasing probability. Now let's move to the last step, calculate the total market share. So I have 4 different customer areas. First of all, if you look at the map, these 4 numbers represent total customer expenditure from each customer area. So total will be 200,000. So I don't want to write too many zeros, so I use 200. It basically means $200,000. So it'll be $200,000, 200K. So $200,000 will be spent from customers in customer area A. $100,000 from customer area B, and $300,000 from C, $200,000 from D. Total spending for all 4 areas, so A plus B plus C plus D, adding these 4 numbers, you get $800,000. The total spending for the entire region is $800,000. Now let's look at each area. So for those who live in customer area A, they will spend $200,000. The question is, how much of these $200,000 will be spent in the proposed store, and how much of these $200,000 will be spent in the existing store? So obviously, we can use that percentage from step 3. These are the percentages you use. So for $200,000 times the corresponding percentage, which is 54%, 0.540, 0.50, so 108. So basically, out of these $200,000, $108,000 will be spent in the proposed store, and the rest will be spent in the existing store. So it will be 200 times 0.46, you get 92,000. So $92,000 will be spent in the existing store. Similarly, we can do this calculation for customer area B. Total customer are going to spend about $100,000. So out of these $100,000, about 0.803 will be spent in the proposed store. So you will have $8.3 thousand spent in the proposed store, and the rest will go to the existing store. So $100,000 times 0.197, that's the probability, purchasing probability, you get 19.7. For those who live in customer area 4, they are going to spend in total of $300,000. And in this case, the proposed store will capture 100%. So all $300,000 will actually be spent in the proposed store, and 0 will go to the existing store. The existing store will not capture any dollar amount. For the store customer area D, it's opposite. The proposed store will capture nothing because it's 0%. It's capture nothing. That's why 200 times 0, you get 0. Nothing will be spent in the proposed store. Everything will be spent, 100% will be spent in the existing store, so which is $200,000. So with all these numbers, now we can calculate how much dollar amount will be spent in the proposed store, combining 4 different customer areas. So we will have to add all these customer spending. Okay, 4 numbers, adding them together, we get a total spending in the proposed store. So will be 108 plus 80.3 plus 300 plus 0, you get 488.3. So $488.3 thousand will be spent in the proposed store. And for the existing store, we do similar procedure. We add these four numbers. Will be 92 plus 19.7 plus 0 plus 200. It gets 311.7. So in total, $311.7 thousand will be spent in the existing store. So now let's look at the market share. So total spending for all customers combined in 4 different areas, $800,000. So out of these $800,000, $488.3 will be spent in the proposed store, and the rest, $311.7 thousand will be spent in the existing store. So now let's look at the market share. The market share for the proposed store is 488.3 divided by total, which is 800. So you get 0.610. Basically, the proposed store will capture 61% of market share. For the existing store, we have 311.7 out of total of 800. You get about 0.390. So 93% market share will be captured by the existing store. So total is 100%. So that concludes the example.